Hello and welcome. Thank you so much for coming. My name is Danielle Wuchenich. I'm a co-founder of Liquid Instruments. And we are thrilled to be here in Munich at the iconic BMW Welt. It's an organization that, to me, symbolizes sophistication and excellence in engineering. So it's a real honor to be here. Thank you so much for coming. Thanks. Liquid Instruments was spun or born out of measurement technology for gravitational wave detectors. And many of our founding team worked on the gravitational wave detector LIGO, which is a Nobel Prize-winning technology for the first direct detection of gravitational waves. And our team also worked on LISA, this planned space-based detector. And at Liquid Instruments, we believe that our mission is simple but ambitious. It's to help scientists and engineers do their best work. And that work requires transformational tools and instrumentation that can evolve as quickly as your ideas. And so today, we're going to talk to you about what we've worked on and what's to come in the company for Liquid Instruments. So the company's 10 years old, and we've grown to 100 employees spread across 4 continents. You'll find our Moku devices used in 1,000 organizations around the world, and we're up to 10,000 Mokus and counting. Moku is our family of products. It's a test and measurement device, and you can see the 3 devices that we have on the market today. And Moku has high-speed inputs and outputs, and at the heart of every Moku device is an FPGA. The FPGA can be reconfigured to run in a variety of instrument modes. And so at 1 minute, you can run it as an oscilloscope, and look at your signals in the time domain. And then you can switch it, and instantly, within a matter of seconds, the FPGA will be reconfigured. And you can look at it in the frequency domain using, let's say, a spectrum analyzer. The best thing about Mokus, though, is that it gets better over time. And our suite of instruments has grown to now have all kinds of measurement tools, from measurement and analysis to signal generation to real-time control. And orchestrating it all is Moku OS. And that's an operating system purpose-built for test and measurement. So another extensible part of this technology is multi-instrument mode. And FPGAs are getting bigger and bigger all the time. And Moku OS is an absolute ninja at slicing and dicing the FPGA. This lets you run multiple instruments on the same hardware. The way that we do that is we slice up the FPGA, and we can run multiple instruments in different regions on the chip. And this has a few great implications for what you can do. So you can wire up multiple instruments together, and all of them are on the same physical chip. And so you get these amazingly high-speed, lossless digital interconnects running at 20 gigabits per second. So this lets you wire up a whole bunch of instruments together. And anyone that's used a PXI chassis might find the UI familiar. But instead of having hardware modules that you're installing and physically connecting, all of this is done on chip. In a single device. So you don't have cables, you don't have a rack, it's just one reconfigurable, powerful device. Multi-instrument mode, we launched that 4 years ago. It's come a long way, and this is something that we're getting ready to have a big refresh on. In a few months, we're introducing Moku OS 4, and with that, you'll find a few new improvements. The first is a refresh for multi-instrument mode, and you can see here how that's going to look. It'll get a nice refresh to the UI, but it'll also include some more features that'll make it more versatile. Sometimes our existing instrument set, though, isn't enough, or you need to do something truly custom. And Moku Cloud Compile will let you do that. So if you want to code or compile or use the FPGA yourself, this is a tool that lets you do that. So here you can get straight into it. You can use VHDL and implement your custom processing. And this lets you implement something entirely new than you had already. But you can also use our existing set of instruments to go in and out with, to read in and out your custom creation. Later this year, or earlier this year, I should say, we added Verilog support and IP cores. And coming later this year, we'll have support for faster sample rates and on-premise compilations. And then stay tuned for next year. We're going to be getting integration with simulation tools so you can get even more sophisticated designs. And we haven't even stopped releasing new instruments either. So in the last year, we released a new instrument, the time and frequency analyzer. And this is something to do event counting. And you can count events with less than 20 picoseconds timing jitter. This lets you count trillions of events or capture trillions of events losslessly on your Moku. Coming later this year, we'll be adding G2, and that's the G2 correlation function. And that lets you do photon correlation. So if you're looking at coherence properties like bunching or anti-bunching, normally the way that this is done is you do a whole bunch of post-processing and you generate a massive amount of data. Later this year, we're going to be adding G2 on device, so you can actually calculate G2 in real time on your Moku. Our users in quantum applications are really excited about this. We also added support for Vision OS, which is for to use the Apple Vision Pro in your lab. So anyone that's in an optics lab, I think will appreciate this, where you can see just how cool you can set up your UI to configure your instrument. Also this year, we launched our first AI features. So the first one is this integrated AI help. And this lets you ask a Moku agent for a whole range of things. So for example, it's an AI that we trained on our documentation. So it's looked at our internal documents, our user manuals, our application notes, and it's really powerful. It's built right into the Moku app, and it can help you get instant answers. So here you can, in your language of choice, you can ask it a question, and it'll give you answers to all kinds of things, like what's this new setting or feature do? How do I configure my Moku? Simple or complicated debugging as well. It's great. One of the most transformational technologies that has emerged in recent days is neural networks and just how they can be used to solve a whole range of problem classes. Our users are really interested in this technology, but implementing them in the real world has been a challenge. A lot of times they're just confined to being run on a computer. So inference is often done on CPUs or GPUs and connected over a network with milliseconds or hundreds of milliseconds of latency. Until now, the Moku neural network can run directly on your Moku, and that actually lets us connect up signals using Moku's I/O, so we can get physical signals in and out with sub-millisecond latency. It's pretty great if you're wanting to get something up and running and have it on hardware in your lab. The Moku neural network is already available, already running, and something we're really excited about. It can enable all kinds of new things, such as adaptive denoising, advanced signal analysis, inline intelligence for real-time decision making. Every day, users are using Mokus in the wild to do their work at a whole range of different organizations. This is just a few of our customers that are using Mokus, and we can hear from a few of them.
So what I like most about Moku is that it's so versatile on the one hand, but it also is powerful.
Like the best thing about Moku is this whole aspect of software-defined instruments.
Versatility of the Moku Go, right? So it looks like a simple machine, but actually it can achieve a lot of functions which you need a separate box to achieve in the lab. So.
Once we got it and opened the box, we could immediately measure. We didn't have to go through any kind of programming or understanding the functionalities. It just kind of plug and play for us.
Another surprise is your entry device is ridiculously cheap. Like I've seen for much less hardware rip-off prices.
I think I even get a demo from other companies, so it's actually very expensive. So that's 10 or 20 times more expensive than Moku Go. So it turns out Moku Go can achieve almost the same functionality we need. So
it was extremely intuitive to work with.
Nothing to compare, like software-defined instrument. Yeah.
I would tell them that they should definitely get a Moku instrument.
I guess you just try it, you'll never regret it, so you'll find how magic it can be.
Stay strong, keep innovating.
So as you can see, Moku has come a really long way in 10 years, and we're so excited for the next phase of the company. Thank you, everybody, for your support and helping us get here. We are so excited to show you what's next. I'd like you to join me in welcoming our CEO and my co-founder, Daniel Shaddock, as he tells you about the very exciting things that are coming.
Thanks. Hey, everyone. Thanks, Danielle, and thanks, everyone, for coming today. It's great to be here in Munich. It's such a spectacular location. Got some really cool stuff to talk about today. So I get to talk about what's coming next. There's a lot of people working very hard on this right now, and so I hope you like what you're going to see today. One of the things that's really challenging about Mokus, and something we really try very hard to ensure, is that as the devices get more and more sophisticated and more capable, that they don't get more and more complicated, and we maintain that ease of use that Mokus have become synonymous with. And that's an incredible challenge, because often these things are diametrically opposed, that adding more and more features, it's very easy for the thing to become unusable, and really everything that we do is trying to drive towards this simplicity and making our users basically work faster and be able to do more. And today I'm going to announce technology that takes a major leap forward in both of these directions simultaneously. And what I'm going to be talking about is a new technology that we're working on. It's a technology preview I'm showing today, so this is not a product today, but it's something we call generative instrumentation. So you've heard that we've made the first steps along incorporating elements of AI into our products, first of all with the AI help, and then with the Moku neural network. This is an even bigger leap forward, where for the first time we're bringing agentic AI to the test and measurement world. I could explain how it works, but I think it's easier if I just show you a demonstration of a few different use cases so you can get the idea of what you can do with this technology. So let's do a demo. So this is the new multi-instrument mode that's coming out in macOS 4 in a couple of months. And I can tap on one of these slots here, and you can see at the top right here, I have a new instrument, this generative instrumentation. So if I click on that one, it brings up a prompt, and it says, what would you like to build? And so this is a way for me to tell the Moku agent what instrument I would like it to build for me. And so let's choose something simple to start with. Let's choose a bang-bang controller as an example. So a bang-bang controller, there's two things interesting about it. One, it's the coolest name of any controller. And the second thing is it's fairly simple, so it works well for this demonstration. So I've asked the agent to create a bang-bang controller with upper and lower hysteresis thresholds. When the input's above the upper threshold, the output should go to minus 100 millivolts. When it falls below the lower threshold, the output should go to 100 millivolts. And we hit build. And it goes away, and it builds, and it takes somewhere between 3 and 15 minutes, depending on the platform, depending on the complexity of what you're doing. There's a lot of work going on behind the scenes. This agent is finding the information it needs, figuring out the algorithms it needs to implement, and then going ahead and compiling that system so that it can run on the FPGA. And when it's finished, you see this, and that's great. So I've built an instrument, but we're all scientists or engineers here. We need to know what this thing does. So how do I trust this thing? Well, there's a few things that we can do. The first thing is we can ask the agent to describe that instrument. Tell me what this instrument does. And so we click there, and it gives us a plain language version, quite simple, of exactly what it built. What did it implement when it built that instrument? It explains not just what it does, but how it works, and then also how do I use it? What do I have to do to use that instrument? So that's great. That may give some people some reassurance, but what if we want to go a little bit deeper? What if I really want to dig into the details and see how that instrument works? Well, as an intermediate step, it produces VHDL code that then gets compiled. So I can open that VHDL code in Moku Cloud Compile and see exactly, bit for bit, what that instrument is doing. Now, in the case I'm going to show you today, the Moku agent got it pretty much exactly right. It did exactly what I wanted it to do. But you can imagine more complicated cases where it doesn't quite get it right. Maybe it only gets 95% of the way there. Well, that means I can come through and look at it, and I can edit that directly and modify that to build on that to do something even more sophisticated I haven't thought of before. So this is cool. So this is looking at the code that I have access to. It's already compiled. It's already running on my FPGA. The last way that I can check that it works is really the way that I think any Moku user would think of first, and that's using the Moku's superpower, which is that it can run multiple instruments at the same time. So I can debug this generative instrumentation with a waveform generator and an oscilloscope. So here I'm using the embedded waveform generator in the scope. I can tickle that generative instrument with a certain input. I can record its output. And if I do that, this is what I saw. So this is the real output from an instrument that's generated by the Moku agent. So I'm putting in a sawtooth wave as the stimulus signal, and I can set the controls, as I was told in the description. And you can see that the controller, the blue lines here, do indeed switch back and forth, just as you would expect for a bang-bang controller with hysteresis. So that's great. That's obviously a very simple example. We're going to go through some more complicated ones now, but I just wanted to pause here for a moment and think about what we're seeing, because when I first saw this, I didn't really quite know how to feel, because it's doing something I've never really seen before. I use AI a lot. I use ChatGPT a lot. I think, but most of the things that AI does are computery things in and computery things out. So, for example, I type something into a prompt and I get text back. Or maybe I put something in a prompt and I get an image, which is really just pixels changing colors on a screen. Or a video, pixels changing color on a screen as a function of time. But to do what we just did, even a few years ago without using this technology, would have required me to tell an engineer, I'd like you to build me this system. It would require that engineer to maybe collaborate, build a design, to identify components, to fabricate circuit boards, to manage the supply chain, to build this thing in a factory, to ship it across the other side of the world, to have a DHL delivery person schlep it through the rain to give it to a shipping and receiving before I even get to receive it and turn it on. Whereas that process takes months at best, and what we've done here was literally less than 5 minutes. So I think it's one of the first examples that I've seen in our industry of generative AI being used to produce what previously was a physical artifact. And I think that's quite interesting. So let's do another example, a little bit more complicated now. We'll pick Gen Inst, and it asks us what we'd like to build. I'm going to ask it to create a driver for the TMC429 motor controller. So this is a chip that I don't know anything about. I'm not telling it anything about this chip, other than I want these clock signals, these digital ins and digital outs, and where to put them. But the agent goes out onto the internet, it finds the data sheet, it reads the data sheet, ingests that information, it develops a protocol, and then it implements that protocol in the system. And it worked. It worked the first time I tried it. So now I want to test it. So this one's a little bit more complex to test. So there's a third way that's built in to this generative instrumentation, which is AI configuration. So now what I can do is I can tell the Moku to generate a test configuration for me. So I hit go. It knows how to test it because it knows what the design is, it knows what it's supposed to do, and it understands the Moku universe. And sure enough, it builds a waveform generator, and it builds a logic analyzer, puts them together. This happens instantly. This doesn't take minutes. This happens in a second or two, because this is just it reconfiguring. And I can actually extend this to non-generative instruments. If I just want to set up my Moku in a new way, this is so useful that we've added a new little AI icon up the top here, on the top right. And if you click on that, you get a different prompt, which allows you to configure your Moku. And you can ask it to do random crazy things. So let's do an example here. Set up my Moku Pro to generate a modulated signal around 50 kilohertz with about 20 kilohertz bandwidth and evenly spaced sidebands. Attenuate frequencies of signal below 55 kilohertz and apply 5 dB of output gain. Show me it in the frequency domain and the time domain, and make sure that these signals are available for observation and measurement. Goes away. A few seconds later, it comes back with this. Populates the Moku. It figured out it's going to use an arbitrary waveform generator to develop this signal. It's going to have a digital filter box to apply the filtering and the gain, and it's going to have a spec and an oscilloscope to look at these signals. But it doesn't just configure multi-instrument mode. It actually goes into those instruments and configures them live. One of the cool things about this is it's fully auditable again, not with VHDL code, but it uses the Python APIs that we all have access to configure our Moku. So if you're learning how to use the Python API and you want to know how to do something, you'll just be able to ask it to do it and then come back and look at the code and see exactly how it works. So again, we have full auditability of the code, so you can understand exactly what's being done, make sure that it's OK, and potentially improve on it. As I said, it configures the instruments as well, so just to prove that's true, this is the result of that command. It's configured an arbitrary waveform generator with the appropriate signal. I can look at it on the spectrum analyzer here. In blue is the original signal. And then it's configured a custom filter up in the top right to apply the filtering requested. And you can see the results of that on the red signal on the spectrum analyzer, and it's given me those signals in the time domain. Pretty cool for somebody who's new to Moku, somebody who's doing complicated things with Moku, or somebody who just wants to do things faster with the Moku. I think this will be a real game changer for us. Here's some other examples of prompts that we've been playing with that all work. So there's these two distinct areas that we're talking about now. One is the AI configuration, and the second one is this generative instrumentation. So we think this is going to be quite revolutionary. We have the technology working today in-house. We're going to have it in a situation where we can start working with users to trial this technology before the end of the year. And you can sign up to be part of that early access program here at this URL and get all the updates. And it'll be the product we expect to be shipping in 2026 to all of our users. So that is generative instrumentation. So we think it makes the Mokus more powerful but easier to use than ever before, which is, as I said, one of the things that our users love about Mokus. One thing that users want, though, is they're always asking for more powerful hardware to run our software on. And so those things, there's really four main things that we hear time and time again that people want. They want higher bandwidth, they want more channels, they want digital I/O, and they want lower noise. And so very pleased to announce today that we've been working on this for a couple of years now, and I'd like to introduce you to the new product. So that's Moku Delta. We have the first one in existence over here for you to come and have a look at later on. It's pretty kick-ass. How do we do on the higher bandwidth? Well, we have more than 3 times higher bandwidth than the Moku Pro. We have double the channels. We have the first digital I/O in our flagship model and the most digital I/O in any of our systems, much higher speed. And we have 1/3 the noise of our Moku Pro, our current flagship for low noise. So yeah, the team have done a fantastic job and very excited to share it with you. There's a couple of really cool things about the Moku Delta. So I think for a long time, when we first started the company, I used to joke that our hardware's okay, but it's the software that really makes it sing. So this is no longer true. This hardware is awesome. So this is the world's highest bit depth 2 GHz scope. This is a scope I would want to use. It's got analog inputs that are simultaneously sampled, all at 5 gigasamples, and that doesn't reduce that sampling rate as you turn on more channels. So it's 5 gigasamples per second all the time, and it's 14 bits. We have, as you saw with a lot of that animation, is on the input signal conditioning. It's very sophisticated signal conditioning, and that's what allows us to get to less than 10 nanovolts per hertz of input noise. We have ADC blending as we do in the Pro, but it's been supercharged for the Delta. So blending is where we have a dedicated low-speed ADC to dramatically improve the precision and the noise performance at low frequencies, which is something often challenging for high-speed ADCs. So here we have a 20-bit ADC on every single one of those 8 inputs. We give that signal to the FPGA along with the 5 gigasample 14-bit signal, and it implements a frequency-dependent crossover network to make sure that you get the lowest noise floor from DC to RF, as well as a perfectly flat transfer function. So it's really cool technology, and the blending actually enabled us to make a huge number of design simplifications to get to that noise floor. It's a huge amount of data going through this thing. It's 1.8 terabits per second of I/O coming in and out all the time. And some of that is on the DAC side, where we have 10 gigasample DACs. And something a lot of users are very excited about, which is 100 gigabit per second QSFP ports. So this will allow you to have very high transfers between Mokus, from Mokus to logging systems, and things like playback and record. It's going to be really important. We also have a pretty sophisticated clocking system. So this is the new interface that will be coming out in macOS 4, which shows you exactly how that clocking system can be configured. So we have a range of different references that all dominate over different frequencies. So it's really blending for clocks, where we have a low phase noise system on the VCXO. We have an oven-controlled crystal oscillator that has great stability and accuracy at intermediate frequencies. We have a 10 and 100 megahertz clock reference in and out, and we have an inbuilt removable, user-removable GPS module that allows you to get 1 pulse per second signals to all of your systems in your lab, as well as control the absolute stability and traceability of your clock for the Moku Delta. So yeah, our best clocking system by a wide margin. And we have multi-instrument mode. So we also have the biggest FPGA in any of our Mokus in the Moku Delta. It's even bigger than the one in the Pro. And so we're making multi-instrument mode a lot more flexible. We're allowing you to have up to 8 slots, 8 instruments running simultaneously in the Moku Delta, and to really trade off the sample rate with the number of slots that you have. So a lot more flexibility and configurability in multi-instrument mode, where it really does fulfill the promise of replacing an entire rack of equipment with a single device at a fraction of the cost. This wouldn't be possible without a fantastic team. So we really are a global team now. We have offices in Canberra, offices in Melbourne, offices in California, an office in Sweden. We have a team in China, and everybody's really been pushing very hard to get this out as quickly as they have. We were asked the team to do some very unreasonable things to meet this schedule, and I have to say they've really risen to the occasion, so thank you very much. I'd also like to let you hear from some of those team members directly now.
So yeah, I started out my career as a researcher in physics.
As Director of Product, I've been working for the last several years with our users, trying to build the best possible device that we can.
One of the exciting things over the last few years is seeing how our users have actually been able to use these devices in ways that we ourselves hadn't even thought of.
There's so many Mokus around the world now in all sorts of places, in science and industry and research and technology, and that's really great to see.
That real core of just smart people building things that they want to use themselves when they go into the lab, that's actually survived really well, which is one of the things I love about Liquid.
When I joined, we only had 1 Moku device. Now we've got 3 Moku devices on the market, and we're excited to be releasing a 4th Moku, the Moku Delta.
So what this means for users is that they have more flexibility and more customization options with their Moku. It can obviously measure more channels, generate more channels, as well as run more instruments simultaneously within the one device.
We've been able to develop 15 new instruments. Year after year, we're able to release new products for our customers and really take our software-defined test and measurement approach to the next level every time.
The Moku Delta is going to be the thing that I would want to use as an engineer. It's got more channels, higher bandwidth, it's got digital I/O, it's got high-speed streaming. If I still picked up a soldering iron day to day, and unfortunately I don't, but if I did, I would want a Moku Delta.
So the Moku Delta is our bigger, faster, stronger version of the Moku Pro. Obviously we've got more channels, we've got higher speeds, and we've got a much larger FPGA to work with.
We've been able to put huge amounts of work into using the latest technologies to be able to lower our noise floor to 3 times lower than our previous product.
I think that the Moku's multi-instrument mode epitomizes the power of our approach to software-defined instrumentation. There are literally billions of ways that you can combine our instruments together to do whatever it is that you need.
So with our blended voltage-controlled oscillator, ovenized oscillator, and the GPS disciplining on the back there, the Moku Delta is going to be the best frequency reference that you've got in your lab. We have configurable 10 and 100 megahertz reference outputs that you can use to connect the Moku Delta to the rest of the equipment in your lab and really discipline the rest of your clocks to the same time base as a Delta.
Even if you're doing something entirely new, the Moku will let you do it. And not just what you want it to do today, but what you want it to do tomorrow.
I think that the Moku's approach to software-defined instrumentation is going to transform the test and measurement industry. I think that it will change the way that people use test and measurement equipment. I think that it will change the way that technology is developed.
Moku's addictive. That kind of addiction to Moku, that love of Moku, really means that we have very strong repeat business, lots of users coming in for their second, third, and onwards Mokus. They just love it. I love it too.
So yeah, the team worked really hard on this one. So everyone watching back at home, thank you so much for all your hard work. And it's great to finally be at this day where we get to share it with the world. So that's it, Moku Delta. It's available to order today. It's going to be shipping, first shipments in August, maybe a little bit earlier. We might squeeze one out in July. And yeah, really excited to share it. It's got a lot of cool new stuff in it. And there's a lot of cool stuff coming across. It's not just the new hardware, but as you've seen, advances in our software. New instruments are in the pipeline as well. You'll be hearing about those soon. And a bunch of new AI technologies that will allow you to work much, much faster, get more done, and make more progress in your careers. Of course, we have a very complete ecosystem now. We have the hardware, we have the AI, we have our instruments. It's supported across a whole range of platforms, so we want to support any way that you want to use our devices. We want to support that. And it's all built on top of a very solid, custom-built foundation of Moku OS. That means it's a scalable, extensible platform for the future. Thanks very much for coming today, everyone. That's all I have. Thanks for braving the heat. And yeah, enjoy looking at the Delta, and I'm keen to come out and talk to everyone after this. Thank you so much.